Welcome to the Algebra Solver, where we solve problems in algebra, calculus, statistics, and other math problems. Our target target audience are those students who are very weak in math. So if you find this boring or too slow, you can forward the video, or you can play it at a faster speed. And if you're already a good student, you probably don't need these problems here. Alright, this is a problem involving solving for x. Solve for x using the quadratic formula. Again, quadratic formula, that's the method of solving these given quadratic equations. In this particular case, 2x squared minus 7x minus 30 equals 0. Since this is a quadratic equation, we expect two values for x that will satisfy the equation. We call it the roots of the equation. According to the fundamental theorem of algebra, if you have a polynomial equation of degree n, then you will exactly have n roots or n solutions. Not more than n, not less than n, but exactly equal to n. In this case, n is 2, because this is a quadratic polynomial equation. So we expect two solutions. And that solution could be repeated two solutions, but we must have two solutions. In fact, the ink we have regarding the two solutions is in the quadratic formula here. The quadratic formula, there's a plus and a minus. Okay, now the strategy for us is to, you can find it here, is to transform or manipulate the equation so that it will be of the standard quadratic form ax squared plus bx plus c equals 0. Of course, a and b are the coefficients of x squared and x respectively, and c is a constant. Once you have manipulated the equation into this form, the standard quadratic form, then we need to apply the quadratic formula, which for your convenience is here on the left. By the way, if you haven't memorized this one, here's a tip. The quadratic formula, you memorize it on a short-term basis right now, and then you get a piece of paper and write down the quadratic formula 50 times in succession, and hopefully by tomorrow you'll still remember it. That's my tip in memorizing hard to memorize formulas. Write it down 50 times, in succession. Alright, so we have the strategy already, and we have the formula. Let's clear up the board and start solving. So we need to follow the form, the standard quadratic form, which means that here we need to make this a positive, and we have to make this a positive. So how do you make a minus 7 become a positive? So an addition instead of a subtraction. And how do you make this also? Subtraction. Now when you subtract a positive number, it's the same as adding a negative number. So this here, negative 7, will become add a negative number, which is add negative 7. So we use the parenthesis very generously so that you will not be confused. So it becomes plus 7. Now how do we attack the constant c? In this case, we should have a positive. So what we will do is this, to make this a positive, so minus that is a minus positive 30, then we can transform this into a plus negative 30. Okay, we have done these integer operations for a long time now. We know what to do, so that we will achieve this to be a plus sign, and this is an addition sign also. Alright, so let's proceed by doing this transformation. 2x squared plus negative 7x. So sorry, there's the x here. 7x plus negative 30 equals 0. Very large numbers. Alright, so we can identify now, let's put it here on the side, that a, look at the formula here, a equals 2, then b equals negative 7. It's very clear in the parenthesis there, and c equals negative 30. That's by identification. So we put it here. Okay, that's by identification. So this is a, this is b, this is c. Okay, let's simplify this. Let's apply now that we have identified a, b, and c, let's apply the quadratic formula. So the quadratic formula here, let's see, x equals, this is the numerator here, denominator here, negative b plus minus the square root of 4b squared, sorry, b squared minus 4ac over 2a. Okay, so things to look out for. This is a negative, and I always make that mistake. And this is the plus and the minus. You don't operate at plus and minus simultaneously, of course. Otherwise, how would you do it? So you have to do that individually. First, you find you solve for x where you use the plus sign here, and then in the next step, you use the minus sign here, the subtraction sign. And this term here is called the discriminant. It's called the discriminant, b squared minus 4ac. And then discriminant, this quantity must be positive for your basic needs, must be positive. The discriminant must be positive, because if the discriminant is negative, then you will be taking the square root of a negative number. What's the square root of a negative number? So it will lead into an advanced field of algebra called complex numbers or imaginary numbers. So for our intents or purposes, this should be positive. Otherwise, we'll be taking again the square root of a negative number. And this is 2a here. Okay. Now remember that the discriminant here, b squared minus 4ac, lead to complications. So you introduce the use of parentheses whenever you substitute values into that discriminant. Right. So what should you watch out for when solving quadratic formulas? Number one, you should watch out for the plus and the minus sign. It's easy to make mistakes in the plus and the minus sign, and the negative and the positive sign. Negative sign, positive sign, addition sign, subtraction sign. Very easy to make mistakes in that area. Another is that don't forget that there's here there are two roots, two solutions, one involving the addition here and one involving the subtraction here. And then another big issue is the 4ac and the b squared, because if they contain negatives, then make sure you don't lose sight of the negatives by using the parentheses. Be generous. Use the parentheses as often or as many as you want, so that you will not be confused with the plus and the minus and the addition and the subtraction. And another big issue, the third big issue in solving quadratic formulas going forward, is taking the square root of the discriminant, because here the discriminant might, discriminants, because the discriminants might contain radicals as well, might contain square roots, cube roots, and then you take the overall square root of that expression. So, square root of a square root. That will be a possibility. Alright, so now that we have given you an idea of how to attack this problem, again, we're slow, we're very detailed, but we're here for the weak guys. We're here for the weak students. So the more details, the better for them. Let's clean up the board. So let us use the quadratic formula and substitute the values of a, b, and c. It's that simple. So in this case, x equals negative b. What is b? Minus 7. Remember that. B is minus 7 here. Okay. And there's a negative here. So it's a negative and negative. So don't forget. That's why I emphasize at all times, use the parentheses, the set of parentheses, use them to avoid future confusion. I myself make a lot of mistakes on this one. So, alright, so, and the next, plus or the minus, this will give you the two values of x. One is the plus, one is the minus when we evaluate the expression later on. And plus minus, and you take the square root. Let's draw a square root here. Let's do the discriminant first. B squared, and we drew the square root sign later on. B squared, that's negative 7 squared minus 4 times a is what? 2, and ac, c is what? Negative 30. We take the square roots of that entire discriminant, the square roots, all over 2 times a. A is 2. Okay. Let's identify this again. Negative b, so that's b, and b squared, that's b squared, still negative 7 there. Alright. And then for a is here. From here, it goes to there, a. And also another substitution for a is here in the denominator. And then c is negative 30. It goes here. Look at the parentheses. Have you noticed here that there's a parenthesis here? There's a parenthesis here. There's a parenthesis here. There's a parenthesis there. So that you will not be confused. So that you will not be confused. Remember, there's a negative here and there's a subtraction here. It's a common source of error. Alright. Take a look at this one. You can pause if you want. And let's clean up the board. So let's simplify this one. X equals, this is, okay, So that would be negative of a negative, so that's a positive. So that's 7 plus minus the square roots of 7 squared. The square root of 7 squared here, that's it. That's a negative number raised to an even exponent. So that will come out, the result will be a positive because it's an even exponent. If it's an odd exponent, it will be a negative. So in this case, negative 7 squared, that will be equal to positive 49 here, right? So let's write that down here, 49 minus. Alright, let's look at this here. We'll put that there. So that's 4 times 2. This is 4 times 2. That's 8. 8 times negative 30. Remember, that is negative 30 there. So 8 times negative 30 is negative 240, right? Negative 240. So we're going to write here negative 240. Don't forget the negative here. We have not eliminated that one yet. It's still there. It's a minus. And of course, below 2 times 2, that's 4. Is it clear now? Okay, let's erase, let's clean up the board. That's now 7 plus minus the square root of 49 minus 240, and we simplify this one. Sorry, where are you? We simplify this one, and just by arithmetic, this will be what will this be? That is 49 plus 240, that will be equal to 289, correct? Alright, let's simplify. Okay, so we now have the solution. X equals 7 plus minus the square root of 49 plus 240. Because minus or minus is plus 240 over 4. So x equals 7 plus minus the square root of 289 over 4. So we simplify this. X equals 7 plus minus 17. The square root of 289 is 17 over 4. So that is the solution. And there are two solutions, the one involving the plus here and the one involving the minus here. Okay, so let's simplify again. So we now have two roots. X equals 7 plus minus 17 over 4. So the first root, just call it x1, using the here the plus. Okay, so that's 7. Oh, sorry. Which is the red pen? Which is 7 plus 17 over 4. That is equal to 24 over 4. So your x1, the first solution, is 24 over 4, 6. Positive 6. Okay, and that is your solution there. The first solution. Remember, there are always two solutions, even if they are repeated. But you perform the plus here, and then you perform the minus here in a separate equation to solve for the second solution. Okay, let's simplify the board here so that we will not be confused. x1 equals 6, or the first one. Okay, so let's solve for the next solution by executing this one, the subtraction here. I hope it's clear enough. Okay, let's clean up the board. Alright, so let's solve for the second value of x. Remember, we are looking for two solutions, two values of x. Why? Because according to the fundamental theorem of algebra, every quadratic polynomial equation must have two roots. Not 3, not 1, but exactly 2 roots. And these roots could be repeated, but there must be 2. So we have already solved for one. And we'll solve for the other one. We simplify it. We had 7. Remember, originally we have 7 plus 17 over 4. We've done the addition already. Now, for this time, we need to do the subtraction. Okay, so this will be x equals 7 minus 17 over 4. So that will be minus 10 over 4. So that will be x equals negative 5 halves. 5 halves. And that is your second solution. We might call this your x2. Your x2. Okay, how can I call it right? So remember, we have the first solution. The first number, it's right here on the top, x1, so what was that, 6, and now we have x2 negative 5 over 2. It's there. We're putting it there so that we will not forget it. So there are two roots, 6 and 5. Of course, we're not satisfied with just arriving at the two roots using the quadratic formula. We need to check that one later on. We need to check by substituting into the original equation and try to see whether there's a balance and the equation still holds true. Okay, so what have we done so far? We have solved the polynomial equation, the quadratic equation, 2x squared minus 7x here minus 30, using the attack strategy here, which is to manipulate the equation so that it will be of the standard quadratic form, ax squared plus bx plus z equals to 0, and then applying the quadratic formula. What we did was to, once we have standardized it, we were able to identify the values, the coefficients a, b, and c. We were able to identify them, and then we use them and plug them into the given quadratic formula. Memorize that formula. Write it down 50 times on a piece of paper. Okay, and so we have the solution, two solutions here. x1 equals 6 and x2 equals negative 5 halves. We're done, but we need to conduct a check. Let's have a check. And our check comes in substituting these values one after the other into the equation. Let's proceed. So let's check. Okay, let's do some checking. We substitute x equals 6. We'll do the first one first. We'll substitute it into the equation. So what word do we have? 2 times x is 6 squared minus 7 times 6 minus 30 is that equal to 0. So this is 6 times 6 is 36. So this is 2 times 36 minus 42 minus 30. Is that equal to 0? And this is 72 minus 72 equals 0. 0 equals 0. Check. That's it. We've done the check. So x equals 6 is a solution to the quadratic equation 2x squared minus 7x minus 30 equals 0. We're not done yet with the checking because we need to look at the second solution, negative 5/2, whether it's a solution to the equation. When we say it's a solution to the equation, it makes the equation true by substituting this value into the original equation. Okay, let's proceed. Okay, so now we substitute the second value of x, which is minus 5/2. So it's 2 minus 5/2 squared minus 7 times negative, remember there's a negative there, 5/2 minus 30. Is that equal to 0? Okay, so simplifying, negative 5/2 squared, that's a negative number being raised to an exponent, which is an even number. So the resultant is an even number also. So in this case, it's remember that's even number there and it's negative there. It comes out as positive. Okay. So there's a negative sign here. So this is 2 times 25 over 4 minus negative 35. Sorry, I don't know why my 5 is always like that. Over 2. Where did you get 35 over 2? This is 7 times 5. That's negative 35, and then over 2. Here the 2 is here. Now remember, we have not touched the subtraction here yet. Okay. Is it clear enough? Is it detailed enough? I hope you gain more confidence in solving these problems. If you make a mistake, just go back. Okay, I make a lot of mistakes as well. So minus 30, is that equal to 0? So as you have seen, you can cancel the, you can cancel the 2 and the 4 here, leaving you with 25 over 2 plus. You know why this is plus? Because this is negative of negative. Negative for negative, you change it to positive, then it becomes a plus, and this one also becomes a plus. You need to change the sign. So we've done that with a lot of times with the integers. So this is 30. Sorry, this is 35 over 2 minus 30. Is that equal to 0? Big question. Okay, so this becomes, sorry, let's use the blue. So this becomes 60 over 2 minus 30. Is that equal to 0? So that's 30 minus 30. Is that equal to 0? So that's 0 equals 0. And we have solved the problem. We have proved indeed that, let's go up, that x equals negative 2 is a solution to the equation 2x squared minus 7x minus 30 equals 0. Proved. We have already arrived at the solution here, but we have checked, and therefore that completes our solution. By the way, I know this is very slow, but you know, we are addressing the very weak students. The slower the better for them, because anyway, with the video player you can fast forward the video anyway, and you can increase the speed of the player. So there's really nothing slow here, because you know, you can just speed it up. Thank you, and see you in our next problem, and I hope that you gain confidence by just solving this problem. Thank you, and see you in the next problem.